Hello class, welcome to the first lesson of quadratics. Today we're just going to be looking at developing plans to solve problems. Because it's largely a review of grade 10 and grade 11, we're going to, before we look at the skills and all the things you have to be able to do, we're going to get out on the table in this lesson the skills that exist, but the ideas of quadratics that we recall. And so in class we would probably brainstorm some lists of skills. But the focus isn't going to be on actually solving the problems, but is how to solve the problems. And so this does seem to be the most challenging part of quadratics. And so we're going to first just look at how to solve problems. So to start, you want to think about what the three forms of quadratic are, and what do each form tell you most easily. And then what you'd want to do is, and we do this in class, is get a set of strategies and skills that we need to develop, that we really need to work on in this unit. The big idea for the unit is that different representations of quadratics, meaning graphs or like the three different forms, the equations, they tell you different things more easily, and it depends on the situation which is most useful. And so we're going to look in the first two lessons at just different types of problems and what we're actually being asked to do. So the learning goal is actually two goals in this unit is that we're going to talk about in this lesson are things like finding the zeros of a quadratic function, but also kind of finding the roots of a quadratic function, and then developing plans to do that, and then also finding the maximum and minimum of quadratic functions. So the parts of the parabola, so we have the y-intercept, and we say x is 0 because we realize that when x is 0, we've got the y-intercept. We've got our x-intercepts or zeros, that's when y equals 0. We've got our vertex or max-min point, and it involves the maximum value, and it also involves the axis of symmetry. And the axis of symmetry would be the x value of the vertex. The three forms are vertex form, standard form, and factored form. So this is what they look like in general. It's probably helpful to look at at specific numbers as well, because there are special cases. But vertex form, you realize, you get the vertex from it. When x equals h, if you subbed in h, which is really the easiest number to sub in, we get k, and that's the vertex. For standard form, if we subbed in x is 0, that's the easiest number to sub in, we get c. And so we get a coordinate 0, c, which is the y-intercept. And for factored form, the easiest numbers to sub in are the things that give you your factors, or your roots being 0, the factors of the question. And so in this case it would be s and t. But if you subbed in s or t, you get 0 for both of those. You can also see factored form in this way, and there's other ways to see it too. But it's in general, it's when you've got a product of two things, two linear terms, and then in that case, and it's just like the restrictions from unit 2, but the zeros are just a little bit different. Like this would be negative b over a, negative d over c. And again, you can look at an example like 3x plus 1 and 2x minus 1 and see what those roots would be. But those give you y equals 0. So those are actually coordinates. Negative b over a and negative d over c are when y equals 0. So first question we're going to look at is the platform. So we've got a situation where a golfer is hitting a ball in the air in the line towards a power line. So we want to actually see if the power line is going to impact the shot. So will the golf ball hit the power line? And so what the question is really what do you know, what do you need to know, and how will you get there? We're not actually going to solve this question. So we're saying well, we know that the y-intercept is 100. So you could draw a quick graph where it starts at 100. You know it's going to hit the ground somewhere when time is gets to be up there in seconds. But what we want to know is is the quadratic ever going to equal 185? And so there's a couple ways you can do it, and so that's how you'll get there. So the platform, we get the y-intercept, we know the parabola opens down. We're being asked if the ball hit 185. That's kind of translating the words into just another way of looking at it. And so option one is you could complete the square to get the vertex. So this is where you're kind of just thinking about, okay, how are you going to get there then? And so you just see if the ball is going to actually go 185. And so if you have the vertex, can you easily figure out if the ball is going to hit 185? Option two, you could just sub in 185. And then it's going to be a matter of like probably moving the 185 to the other side using the quadratic formula or factoring. But then the question is, how do you know if it's going to hit it? What kind of roots are you expecting? Are you expecting no roots? What does that look like in the quadratic formula? Are you like what kind of are you expecting two positive roots if the ball hits the power lines? And so it's really just thinking about the question. Is it going to hit 185? We'll come back to this question and solve it later. Next question, if the ball hits off the platform, how long is the ball in the air? So you can, again, draw it. We want to know really what that zero is. That's what we need to know. And how are we going to get there? We can factor it or use the quadratic formula. And then the seagull question is very similar to the power lines. Like we're just kind of dealing with the same issue where we can sub 125 in. Business question, we've got a profit equation that's like opening down. And again, we asked like, what do we know? Well, we know it starts at -15 because of the y-intercept. Will it be possible to break even? Well, then the question is like, is it going to go up to 0? Is the profit ever going to be positive? And so you got to find out possibly what's the vertex. And if you can find out the vertex, then you know if the business is going to break even. You can also find the zeros. So use the quadratic formula. What kind of zeros are you expecting? Like, is it if you get x's, if only zeros are negative, then is it going to break even? If you don't get zeros, what does that look like in the quadratic formula? And so those are like the kind of things you want to think about in terms of like how are you going to get there? I'm going to use a quadratic formula, and I'm going to find the zeros. And if I don't get zeros, I'll know that it doesn't break even. And so that we can actually use the quadratic formula later. But we just want to look at not actually solving these questions, just what are you being asked? Problem 3 is maximizing revenue. You've got a revenue equation, and x is going to be the price increases. And so like we know a whole bunch of things. Like we know it's factored forms, so we potentially have the zeros. We know if we drop the price -30, if we do a -30, we're going to have zero money. We know if we raise the price so that this is 0, we're going to like break even as well. We're not gonna make any money. And so the question is like, what do you need to know? Well, I need to know the vertex, the maximum. How am I gonna get there? I know if I know the zeros, then I can just use the strategy of axis of symmetry to find the vertex. Linear quadratic system. What do you know? What do you need to know how we get there? I'd probably draw a sketch. We've got like a skeet shooting is kind of, you can like YouTube this. It's something being thrown in the air and then someone shooting at it. You can draw a sketch like this starts at height of 2 meters and then it goes up and down. You might want to like. You could potentially find the zeros, you can find the vertex, you find a lot of things, but the question is it going to hit this bullet that's traveling at this kind of distance? And so this is a line, it starts at 1 and goes up, and potentially it will because it's going to go up pretty high. But the only question is like, does it catch the skeet that starts higher? So how long will it take the bullet to hit the skeet? How high off the ground will it be hit? So what do you know? Well, you know you've got a quadratic and a line. You got the y-intercepts of each. What do you need to know? You need to know when these two things are equal. So how are you going to get there? You could set them equal and then get standard form. So 0 equals standard form, and use your quadratic formula. And it's probably going to be quadratic formula because there's going to be a decimal involved. But you could also factor it and see. But roots is actually like finding using the quadratic formula to find out if you have an answer. You could get two answers. You potentially are going to get your answers and then find the heights afterwards. And so because it says how high as well, but t is how long will it take, so the time that it's going to hit. And so again, we're just looking at reading these questions and asking ourselves, what are we going to be asking? Like, what kind of skills do we need? And it's okay right now if like you're not sure, okay, when I sub something in and then I solve, I'm not sure how to solve. When I'm not, like, I know I got to get the zeros, but I'm not sure exactly how to get the vertex from there. That's a skill that we're going to develop using the axis of symmetry. I'm not sure how to like complete the square here, or I'm not sure how to use the quadratic formula. I'm not sure how to like find the zeros with the quadratic formula or factor this. Those are skills we're going to develop. Right now, we just want to make sure it's clear to us what we're being asked, which of the key features we're being asked for, what form are we looking for, what form would be helpful, like what are you looking for. And so this is like a graph that you can go back to. This works for a lot of the questions, anything being launched in the air or business being conducted will form something like this. But you're just asking like, what's the plan? And don't worry about solving it. Just look at